What's going on, YouTube? I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today we're talking about one of my favorite packages in Python, and that is NumPy. And it goes hand in hand with pandas, which we'll cover in a second episode. But NumPy is a data processing tool that is very good at taking loads and loads of data and manipulating that in whatever way you need it to, very fast and very efficiently. So without further ado, let's jump over to our Jupyter notebook and we will start. Alright guys, swapping screens, you can see we have a brand new Jupyter notebook open. The very first thing you're going to need to do is obviously download NumPy. If you're using Anaconda, this comes pre-installed in their data science package, so you don't have to worry about it. However, if for some reason your Anaconda version does not have it, you're going to have to follow these instructions. Or if you're using some other Python scripting tool, or if you're using some other instance of Jupyter Notebook that isn't through Anaconda, you're going to need to install this. So in order to do that, if you're within Anaconda, you can just conda install NumPy. But if you need to pip install it, you can just pip install NumPy as well. I'm obviously not going to run these commands because I already have these downloaded. But if you're in Jupyter Notebook, you can run these like this, or the same thing through your command line without these exclamation marks up front. After you have installed, the very first thing obviously you need to do is import the package. So import NumPy, a lot of people do as NP. It just makes it easier to reference and be able to use as you keep calling the package. I'm going to just show you what version I'm using. If you are using a different version, or if you run into an error, maybe a lot of times you could be using an older version or even a newer version than I am when I made this tutorial. So just update your package if you're using an older version. That's the easiest way to take care of it. If you need to use that older version, or if you're using a newer version, just make sure you check the documentation if you're running into error. Some things may have changed. A lot of these are fundamental to NumPy, so I doubt much is going to change, but that could be a source of your problems. Okay. Moving on, we're going to go and make our very first NumPy array. So I'm just going to define a standard Python list. So obviously a lot of you are familiar with this. Let me just print to show you. And there you can see our list. Now if I want to convert that list to a NumPy array, I can very easily. So let me just convert that by saying np.array. And I'm going to pass in that list that I just created. So now when I print it, it's the same thing. The only difference is it loses the commas when you print an array. But now we have our array defined. If you don't want to define a list first, or you don't have a list first, you don't have to worry about that. You can just feed it right into it. So if I make y, let's say I just copy the same values, but I'm passing them directly into the array instead of through a list first. It's going to do the same exact thing. Let me just clean up my output a little bit. And as you can see, it's the same exact array. Now, not only can you do one-dimensional arrays, but NumPy accepts two-dimensional arrays. So if you put those brackets in, now the only difference is when you do two-dimensional arrays, you need to keep your rows or whatever axis you're working on in parentheses within the brackets. So if I say, let me just divide these. So I put brackets around my individual rows. And this is going to, if I print this out, it's going to give us a two-dimensional array, obviously. Here's the first row, second row, just like I put it in the NumPy array. All right. Next, we are going to get some useful information from our arrays. So one thing you're going to want to know is what's the size of my array that I'm using. One simple way of doing that is to just use the .shape function, and that is going to pass you, let me just scroll down a little bit, it's going to pass you the shape of the array. So if you remember, Z was 2 rows by 3 columns, and this is 2 rows by 3 columns. Another thing is you want to know what kind of variables are stored within them. So you can do z.dtype. Dtype is whatever type of variable is used within your NumPy array. So when you print that, it's saying you have a 32-bit integer within there. Now, I defined some arrays up top here, but maybe I realized that my arrays need to be in different shapes, or they're not the shape that I expected. So what you can do is you can actually change those to whatever shape you do need them to be. So for instance, if I remember back up here, actually let me just grab this one real quick. Let me just make this X. So I have a one-dimensional array, so one row of 6 columns. Maybe I need to make this into, 2 rows by 3 columns. You have to make sure that your data will fit. Obviously, if it doesn't, you're going to come up with an error. But 2 rows by 3 columns is still 6 variables. So if I define a new variable, let's call it x reshape, and I can take x and I can do dot reshape. Okay, and I can say I want it to be 2 rows by 3 columns now. And when I print this, you can see that it is 2 rows by 3 columns. I can do the same thing if I come back up here and I say I want it to be 3 rows by 2 columns. It's going to do the same exact thing. All right. Other things you can do if you want to rotate how your array is. Maybe I want the columns to be the rows now and the rows to be the columns. Very easy to do. I'm just going to define another variable here. And what I'm going to take is I'll just take the one I just made. So x reshape. And I'm going to do a dot t as a transpose function. So it's just going to swap my rows and columns. So if I copy this down, print it, you can see 135 was my column originally. It is now my row. And same thing for the columns to rows. Or sorry, the rows to columns. So easy way to swap your array real quick. And another thing, especially when you're using TensorFlow or some of the machine learning packages, your data needs to be in a very specific form. And with TensorFlow, a lot of the times that is your input features need to have their own row. Now, when we look up at the X here, each of the inputs are a column within the row, and we would really like them to be a row with 1 column each, or each in their own row in 1 column. So one way to do that is, let me just define another reshape. So I can take that initial X and I can say I need that to be reshaped to give each line to an input. So each input their own line with 1 column. And so if I pass a -1, 1, what -1 is saying is give me as many rows as it takes to give me 1 column each. So that's what this is going to do. So when I print this new one, obviously you can see it was 1 row, 6 columns. It is now 6 rows, 1 column each. All right, adding another cell here. Other ways of defining new and useful arrays. So sometimes maybe you don't have the values that you need, or you just want to create empty arrays with constant values in them. So Numpy has a lot of built-in features to do this. The first one I'll go over is the zeros function. So if I do np.zeros, and I'm going to pass it in whatever my shape is that I want it to be. So you need to use brackets, or sorry, not brackets, parentheses within here to define what the shape is. So I want to say 2 rows by 3 columns. Now when I print this, okay, it is going to give me an empty array with all zeros with 2 rows and 3 columns, exactly what I told it to do. Other things you can do, maybe you don't want zeros, maybe you need ones. So np.ones is another function. Same thing. Now I'll show you another way of doing this. Maybe I don't want it to define, or maybe I don't even know what the shape is, but I want it to be the same thing as the zeros variable that I just created. So I can say I want it to be, and pass in zeros.shape as my shape, and it's going to give me the ones array, but with the same shape as the zeros. And you can see that's what I did here. Another way of doing this, and it's the same exact thing, it's just a different function to use. You can use _like, so ones._like, and then get rid of the shape here. So I want a ones array like the zeros array. And that's going to do the same exact thing. Additionally, maybe zeros and ones aren't what you want some other constant value. So let's pretend fives is what I'm looking for. So I can say same thing as before. So np.ones, and I want to say it's same shape as zeros. So all I'm doing is defining a ones array, and I'm going to multiply it by whatever my constant value is. So in this case, I'm going to multiply it by 5. So I'm going to go down here, and I'll print my fives array. And you can see all those ones change to 5 now. And you can do that for whatever constant you want. Okay, and as you can see, a lot of these values have a decimal after it. That means all of these are floating points. Now, there's going to be cases where you want to change it, and maybe you want integers because you're about to do some multiplication on it, and you want to keep your integers in the end. So what you can do is you can change the D type in a whole bunch of different ways. So first, let me just go up here. I'm going to grab my ones function. I'm just going to go back to passing in the shape. But when I define this function, I can actually just define what D type I want it to be. So maybe I want it to be np dot a 32-bit integer. Okay, so now when I print this, it's going to give me a whole bunch of integers instead of the floats like before. Other ways of doing it, let me just define another one. So I can just create a brand new array, and I can pass in one of the other ones. So if I pass in fives, and then define my D type here in the same way I just did above, that's another way of doing it. And just printing out my results. And you can see those are all integers now. You can also just cast whatever you're trying to do. So if I have, if I have the fives array, which is the floats as you can see above, but I say as type, which is a built-in NumPy function, and I can say I want it to be as type in32, and it's going to take that and it's going to do the same exact thing as the other ones did, but it's just casting it after the fact. And you can see down there. And lastly, maybe I want to go a different way with it, and I want to the ones array I just converted to an integer. Maybe I need to go back to a floating point. So you can change the D type to maybe a 64-bit floating point. Oh, sorry. So that would be a float 64. And as you can see, it is right back to being a whole bunch of floating points. So very useful, especially when you need to match up D types for any sort of manipulation you need to do with your data. All right, and we will go next with our last creation of new NumPy arrays, and then we'll move on to how you can manipulate it within NumPy. But maybe you don't want constant values, or maybe you just want to initialize it with a whole bunch of random values. So NumPy has a random module built right into it. So you can do np.random, and then depending on what you want to do is what you do next. So if you do .random again, and I want to say that it's the shape of ones. So when you print this out, this is going to np.random.random. This is going to give you values from 0 to 1. So this is going to be a whole bunch of floating points from 0 to 1. If you instead want integers, there's a built-in function for that called Randint. So np.random.randint. Right, and then you have to tell it your upper and lower bounds. So maybe I want something like the pixels from a picture. So it'd be in between 0 and 255, where 0 is my lower bound, 255 is my upper bound. And I need to tell it what the shape of my output array should be. So I'm going to pass in ones that shape again. So now if I come down here and I print Randint, oops, I forgot an S up here. There we go. You can see that it prints out a whole bunch of random integers now. The last thing I'll show you is Linspace, another very useful tool. And so np.linspace, this is going to take, so I'm going to say I want values between 0 and 10, and I want 100 of them evenly spaced out. So if I come down here and print that out, right, you can see that is giving me 100 values from 0 to 10 evenly spaced out. Now you might think, well, 100 should go pretty easily into 0 to 10. It should be, 0, 0, 0.1, 0.2, 0.3. But since it's including the starting position, if you want it to be that evenly spaced out, you need to add 1 to this value that you put for the number of values that you want from the Linspace. So if I do 101 instead, it's going to include that initial one, and it's going to make it what you were looking for. Okay, so enough defining new arrays. We'll move on to what NumPy is really meant for, and that is manipulating data very easily and very quickly. So you can do that in a lot of ways. So I'm just going to define a new array. So I'm going to call it A. And I'm just going to make it a whole bunch of random values. Maybe I'll just do 1, 2, 3, 4, 5. And I will do the same thing. I'll make a second array, and I'll call it B. Okay, so I have my two arrays. Now I can do a whole bunch of different things with this. Like I can add the arrays together just using standard symbols, right? So A plus B. I can do, A minus B. I can do A times B. A divided by B. I can do other Python functions like A to the power of B. That is 2 asterisk symbols. I can do the dot product of the matrices, so matrix multiplication. That is the at symbol. Another way of calling this, again, built-in NumPy function would be A dot B. Both of these will do the same exact things. Let me scroll down a little bit. And not only can you, do this with just array to arrays, but you can actually do it with constant values as well, like you saw before when I defined the 5s array. But I can say I want to take A and I want to multiply it by 5, or I want to do the power of 5, whatever you end up wanting to do. So I can stand by for a second while I print all of these, but I can just print all of these out. And I. Okay, as you can see, these are all here. I'm not going to go through and verify each one of these, but just trust me on the fact that these are all right. And you can see when I did the division, it automatically changed these to floating points. So NumPy takes care of that for you. So you don't accidentally run into a problem there. Okay, and there's also just a ton of built-in functions that go beyond just this simple math functions here. So if I define another array, I'm actually going to define this one with random values, but I'm going to make some of them negatives. Okay, so I have a couple negatives here. Maybe I'll just throw one more in. All right, so I can actually just use a built-in function for absolute value. So np.abs is absolute value, and I'll pass in that array that I just created. Other functions are, I can take the sign of A, so np.sign of A. Same thing with cosine, so cosine of A. I can do np.exp, which is e to the x, or in this case, e to the a, if I pass in a. And lastly, I could do something like np.square root. So sqrt of a. So if I go back up here, let's see. All right, and I'll print all these out. I'm actually getting an error. I am trying to take the square root of a negative number, so it's giving me a warning. So actually, I will just do it, and I will pass in b since I took the absolute value of it, and that should take care of it. Yep, so now I'm taking the square root of all of those positive values. But again, I'm not going to go through all of these, but you can see where it made floating points, it automatically took care of it and gave me all the values I need. So there's a lot more functions. I'm not going to go through all of them. These are the simple ones. There's a ton of documentation out there on NumPy of different things that you can do. But for now, those are the standard ones. Now, when I have big arrays like that, there are a lot of values that I may want from it. So let me just come back up here, copy A. Right, so maybe I want to know what the minimum value is, or the maximum value, or the mean, or standard deviation. All of this is, again, built into NumPy. So I can say I want the minimum value of A, right? Or let me just copy this. Maybe instead of the minimum, I want the maximum value. That's dot max. Maybe I want the mean value. So that's dot mean. Standard deviation is dot std. Other things, the sum. I can take the sum of the entire array, or I can take the cumulative sum. So it's going to take the sum starting from 1 here, adding whatever's behind us, in this case 0, and then moving on to the -4, adding all the values behind it. So it's going to just accumulate the sum till the very end of it. So when I print this, you can see all of that is here. Okay, and it would be very good, especially when you start moving into multi-dimensional arrays. Maybe I don't want the sum over the entire array. Maybe I want the sum only over the columns or only over the rows. There's ways to do that. Basically the same thing if I take a.sum here. Actually, let me define a new multi-dimensional array. So np.array. Let me get my cursor out of the way. Brackets, and then again, when you're making multi-dimensional arrays, you need to put parentheses within there. So some random numbers, comma, other random numbers, and more random numbers. So you have a 3-dimensional array. All right, and we are going to, I'll just print out what that array looks like. All right, you can see we have 3 rows by 3 columns. And now if I want to, let me just add one more so you can see the difference here. Let's try that again. So now it's 4 rows by 3 columns. So if I want to take the sum of it, so again, a.sum, but if I pass in the axis that I'm trying to go for, so axis of 0 will give me the sum of the columns. And we can see that it's giving me 3 values. Again, the columns, there's 3 columns in here. So it's giving me the sum of all of those. If I do the same thing, but I pass in the axis equal to 1, it's going to do the same thing, but it is going to give me 4 values because it's doing the rows this time. So cool ways of doing only a subsection of it. Again, if you have more than 2 dimensions, you can just pass in different axis values to give you what those values are. And it doesn't just work for sum. It's going to work, again, for all of these. Min, max, mean, standard deviation. It's going to do all of that as long as you pass in the axis. Okay. I'm actually going to steal this array again. And just like Python lists, referencing individual values is the same thing. So again, let me print A so you can see that. But I can reference individual variables, individual rows, columns within there. So if I say I want the A at 0, so this is the first row, so it should give me 1, 2, and 6, which it does. That's the way you can do it. You can obviously pass it just like Python lists. I want the last list, so I can say -1, and it's going to give me that. And if I use a colon, so if I say I want 0 through 2, it's just going to give me the subsection of the list. Other things I can do, if that gives me the rows, I can also just say I want the columns. So if I use a colon, is saying I want all of the rows, and then a comma, I can say I only want the first column, which is the 0 right here. And that is going to give me all of the values within all the rows, but only the first column. As you can see, 1575 is the first column here. Other cool things you can do, instead of looking for individual indexes, you can actually say I want all of the values within A where A is greater than 2, let's say, or let's say 3 actually. So I want all the values where A is greater than 3, and that is going to spit out all of the values over 3, but it doesn't keep the position within the array. So one way to do that is instead use the .where function. So I can say np.where, and I want to say where, again, A is greater than 3. So running that, it will give me the position, or sorry, the indice values. So these are the row values right here. So row 0, row 1, row 2, 3. And these are the column values. So easy way to reference where those positions are. And again, even if I just take and pass in those indices into A, it's going to give me the same as what I did before. So you can see that it does check out. Okay, another super useful function that I've found and I've used a lot when I'm starting to process data. So if I go back up and let me steal that random. Yep. So I'm stealing the random array. And this was the array that printed values from 0 to 1, floating points from 0 to 1. So let me just print the random to show you what it is. Let me actually increase the size a little bit. Maybe I want it to be 4 by 5, just so you can see some more values. But you can see all values in between 0 and 1. But if I have some requirement, or maybe this is useful for things like, again, pixels, where you have only values from 0 to 255. Anything outside of that you don't want or you need to correct. So I can actually redefine the array, and I could say, so random equals random.clip, and I can say what my upper and lower bounds are. So maybe I don't want anything lower than 0.25 and higher than 0.75. If I run this, let me space out my outputs here a little bit. So if I run this, what this is doing is saying any values lower than 0.25, I'm going to automatically correct to be 0.25. And any values greater than 0.75, I'm automatically going to make it 0.75. So you can see down here on the bottom, 0.94 was corrected to 0.75. 0.17 was corrected to 0.25. So it's a way of just getting rid of your outliers if you have any, and kind of just reshaping and restructuring your data to what you need it to be. Very useful when you start preprocessing lots and lots of data, and it's super fast through Numpy. And the last thing I'm going to show you guys is, again, very useful in preprocessing data. So you may have arrays where you have missing values or you have infinite values. So if I just define, again, a couple multi-dimensional arrays here, so I'll do 4 values. That'll work. So I will actually change some of these values. So maybe you're going to run into np.nan. So nan is not a number. It's what NumPy uses when it's missing a value, or maybe you get an error. So I'll throw in a couple of these. And when I print A, you can see those values are now not A numbers. So when you start manipulating the data, you're going to possibly run into some errors, or these are going to cascade and start wiping out some of your values. So you'd like to address those, and maybe you want to make them outlier values, or maybe you know the values that you want them to be. So what you can do is you can say, I want to change all those values. So np.nan_2_num. So numpy not a number to a number. And so you can pass in whatever array you're trying to do. So in this case, that would be A. And I'm going to say what those values are that I want it to be. So I'm going to change all my NaN values, and I'm going to make them all zeros now. So I can print B again. And as you can see, all of those NaN values are now zeros. Another thing you're going to run into is infinite values. And this can happen when you're dividing by 0 or dividing by a very small number. NumPy may fill it with np.inf or negative np.inf. So positive infinity or negative infinity. And you're going to want to address that as well. So if I come up here and I change one of these values, let's just make it the last one here. Instead of np.nan, I change it to np.inf. This is positive infinity. I want to take care of those. So one way to do it without doing anything else is go back up to that clip function. So clip is automatically going to take care of positive and negative infinities to make it whatever your bounds were. But if you're trying to fill in NaN values, you can actually just do the same thing right through this function. So by passing in another value here, I can say positive infinity, so POSINF. And I want to say whenever you run into a positive infinity, change that value to a 10. And the same thing for negative, so NEGINF. So change negative infinities, let's say, to negative 10. So now when I run this again, obviously the NaNs have been changed to 0 again, but this infinity value has been changed to a 10. So again, very useful when you're trying to take care of outliers, or you run into errors, or you run into divide by zeros when you're pre-processing your data. It's going to save you a lot of time trying to hunt those down, and it's going to just correct those. And when you start running in or start using real data, again, missing values are going to be a big problem, and you're going to have to take care of them. NumPy is going to automatically record those as NaN values. So easy way to correct it. But that's actually all I have for you guys for NumPy. I could go on for hours about all the other features. This is a fairly good start for a beginner. As I do more tutorials, I'll probably throw in other functions that you haven't seen, but it's just a super powerful tool, super useful when you're pre-processing data. And I recommend checking out all the documentation NumPy has released. I'll put a link into the description. They have a ton of tutorials and a ton of just examples of how you can use it. But for now, that's all I have. Thanks guys for joining me, and I'll catch you next time.